when we're trying to find an angle, the first few steps are exactly the same as if we're trying to find a side. And so in this case, where we're looking for an angle, we're looking for angle theta. Now theta is just a Greek letter that we quite often use to stand for an angle in particular. And so the first step that we always do is, in relation to our angle, we label the side. So this side is opposite, and this side is going to be the hypotenuse. So we're just going to write those in. This is the opposite side, and this is the hypotenuse. That means this third side is the adjacent, but we know nothing about the adjacent, so it's going to be irrelevant to our calculations. And our next step after that was we look at our three ratios. Two old angels skipped over heaven carrying a harp. We say, which one of these is going to help us? Well, as you can see, the adjacent side is no use to us. We know nothing about it. And so anything with the adjacent in it is irrelevant. And so we're going to use the sine ratio. And that makes sense because, look, we know the opposite side and we know the hypotenuse. So if we want to find the angle, sine is going to work for us. So let's write down our formula. And that's sine of an angle x is equal to opposite over hypotenuse. So up to now, it's exactly the same sort of thing as when we're finding a side. The next thing we do is we always fill in. So it's the sine of an angle x. In this case, our angle is theta. So I'm just going to write it like that. Is opposite 3.3 divided by the hypotenuse, 7.2. Now this is where the stage it changes, because we know that the sine of theta is equal to 3.3 divided by 7.2. I want to find out what theta is. And so to do that, I need to do the reverse procedure of sine on the right-hand side. Now, we call that the inverse sine. And the way we write it is sine to the minus 1 of 3.3 divided by 7.2. Whatever's on the right-hand side there, we do the inverse sine of it. Now that comes up on your calculator. Let's just see what that looks like. On your calculator, we have the three buttons, sine, cos, and tan. And you'll notice just above them there is an inverse sine, inverse cosine, and inverse tan. We tan with a wee minus 1 as the power. To get those values, we press the shift button and then the sine button, and that gets me the display inverse sine. Then after that, I just write 3.3 divided by 7.2. And when I do that, my calculator, it says theta is 27.3 degrees. One last thing about your calculator. Up here, you can't just make this out, but this actually says a little D for degrees. And at third form GCSE level, that should always be a little D there. If it's an R or a G, that needs changed, and you can do that through the setup of your calculator. But this should be D for degrees. So here's another example. Let's run through the steps a little quicker this time. First, label the triangle. This is my opposite side. And this time is my adjacent side. I don't know the hypotenuse, and actually, I don't need to know it. It's irrelevant in this. So my ratio is two old angels skipped over heaven carrying a harp. So I need the ratios that involve the opposite and the adjacent, and definitely not the hypotenuse. That has the hypotenuse in it. That has the hypotenuse in it. This one involves the opposite and the adjacent. So let's write down our ratio. Tan of an angle x is equal to opposite over adjacent. And fill it in. So tan of angle, well, our angle here is theta. So we're going to write, instead of x, we're going to write theta this time. Is 6 over 13. And now to find theta, we have to, instead of taking the tan of theta on the left-hand side, we're going to do the reverse procedure on the right-hand side. And the reverse of tan is inverse tan. So press shift tan on your calculator, and then in the brackets, 6 over 13, or 6 divided by 13. and that equals 24.8 degrees. Every time we do this process, every time we find the angle, we always end up using the inverse tan, or the inverse sine, or the inverse cos. If you're finding an angle and you haven't used the inverse, then you haven't done it correctly. But alternatively, if you're finding a side, we never use the inverse. We always just use the sine, or the cosine, or the tan. So here's a couple for you to have a go at. I've labelled these y rather than theta, but we want to find the missing angles y. Can you label the sides? Work out which ratio you're using. Use the inverse sine, cos, or tan, and then find out what size angle y is. Just pause the video and restart it again when you want to know what the answers are.